Good morning, afternoon, or night. Today we're going to talk about monomial square roots. We've talked about square roots that have numbers in them. We've talked about square roots that have numbers that don't go pretty into them. But today we're going to talk about when it's variables. Variables work very similar to numbers. So this square root wants to take things out of this house in pairs, right? All I got to do is, just like I factored the numbers, I want to factor the letters. I have 8 to the 4th power. 8 to the 4th power isn't super clear on what it can be, but we know what it means. We know that an exponent means repeated multiplication. So 8 to the 4th is the same as saying square root of a times a times a times a. And like we just mentioned before, when we pull things out of the square root, don't we pull them out in groups of 2? So now we just got to think, how many groups of 2 are in here? Well, I got a group of a here, he gets to leave. I got a group of a here, he gets to leave. And I got nobody left in the square root sign, so there's no point in writing. So my answer right here is just a squared. All I'm doing is that if I have an even exponent, I can pull out an even group of variables. And the same thing kind of works for the next one, but the next one's kind of weird. Well, b to the 7th is really just, bear with me now, b times b times b times b times b, I'm running out of room, times b times b. I probably should have wrote it better. But we're going to do the same idea. What can we pull out? Well, I got a group of b's, and a group of b's. So I can pull out b times b times b. But I got that one guy left over, so he gets to stay in the square root symbol. So when you simplify with an uneven exponent, or an odd exponent is what people would say, you will have a group that comes out, sorry about that, you will have a group that comes out, and you'll have something left over inside. Now, there's a simpler way of thinking about this. Square roots, or radicals, are the inverse operation to exponents. So when we have a variable here, or a variable over there, what we want to do is we want to do the inverse operation. So if I have this square root of, let's say, x4, we just did that one, but y, 8, z, 10, well, square roots pull things out in pairs. So in my brain, I got to think of how many pairs can I pull out of x to the 4th? Well, how many times does 2 go into 4? Well, you could tell me 2 goes into 4 2 times evenly with nothing left over. Or how many times does 2 go into 8? Well, that goes in 4 times evenly, right? Or how many times does 2 go into 10? That goes in 5 times evenly. So what we can do is we can do a little cheat sheet. We can cheat a little bit, and we can just kind of see how many groups of 2, which is our index, go into each of the exponents. And it works super well when we work with variables, okay? So that's all we're doing. We'll do one more example. We'll do D3, E9, F12. Well, we'll do the same idea. Well, how many times does 2 go into 3? Well, I know that 2 goes into 3 one time, but I'm gonna have one guy left over. And just like we had before, we can leave a guy back in the house. Same thing here. How many times does 2 go into 9? Our index go into the exponent. Well, it goes in 4 times, 4 groups of 2, and one guy's left over because he's out. And how many times does 2 go into 12? Well, that goes in pretty evenly. Okay? That's the intro of it, right? We've been talking 3 minutes. Perfect. Right? Now, we want the same idea, but what if we throw some numbers into the mix? Let me throw a number into the mix. Well, let me zoom back out. I don't even know why I did that. That way you have the example up top. So now what if we do the same thing, but with a number? Let's do the square root of, let's go 50, and then I'll throw some letters at the end. A5, B9, C2. Well, do we know how, if I just had the number, would we know how to solve it? Yeah, because we've done those before. If I just had the letters, would I know how to solve it? Yeah, we just did it up there. So if you could break it up into the 2 parts, you can solve it together. So why don't I break up the 50? Well, 50 breaks up into what? 5 and 10. 10 breaks up into 5 and 2. So I'm left with 2 times 5 times 5. Well, look at that. I got my pair of 5s. So if 5 comes out, 2 goes back in. And now we go back into the variables. Let's talk about the variables. Well, I have 5 groups. I have 5 groups, 5 A's. So how many groups of 2 go into 5? Well, 2 groups go in, 1 guy stays home. He's got nobody. How many groups of 2, which are indexed, go into 9? Well, that's 4 times, and I get 1 guy left over. And lastly, how many groups of 2 go into 2? 1 group. That's your final answer. It's just a combination of dealing with the numbers and then dealing with the letters. If it helps, guys, you can write it all out. If I did it the same way, I'm just going to use the space right above it. If I did it the same way, I could write A. 1, 2 groups, 1 guy left over. 2 guys leave, 1 guy left over. B's. B. How many is that? 7, 8, 9. 1 group, 2 group, 3 group, 4 group, 1 guy left over. I might have wrote that. LOL. All right? And then I can do C's. C, 1 group. Now, how convenient is it to write out all the letters like that? Probably not very, right? So that's why the little trick works out for us. But if this helps, do it. If this is the way to go, do it, because I think it's a very visual way of seeing what's actually happening. A square root sign pulls out groups of 2, and we know we can pull out 1, 2, 3, 4 groups of B, and have 1 guy left over. And let's do one more example before I just let you guys go on your way. I'll give you any number. Great number. Let's do 288. You're about to hate me for this one, because this one's going to be huge. And then we got, let's do some letters. Let's go D5, E10, F. Cool. Well, 288. I know that's 2 and 144. I know that's 2 and 72. I know that's 2 and 36. I know that's 2 and 18. I know that's 2 and 9. I know that's 3 and 3. Yeah, that was dumb of me to pick such a big number. But if I see it, I'm going to write this one a little bit differently. Maybe you can see it, maybe you can't. But I'm just going to kind of go, I got a group of 2, and a group of 3. So, let's move this up, because I should have thought about this a little sooner. This is my unprofessionalism. Okay, so a 2 gets a leave, a 2 gets a leave, a 3 gets a leave. And I got this lonely 2 who's got to go back in the house. And now we'll talk about our variables. Well, I got D. How many groups of 2 go into 5? 2 groups, 1 stays. How many groups of 2 go into 10 E's? 5 groups, none stay, because 2 goes into 10 evenly. And then F, there's only 1 of them. Can I pull out any pairs with F? No, so he stays here. And then we just simplify, we get 12, D2, E5, root, 2DF. Well, I appreciate you all for following along, and I hope you guys have a great day. Bye-bye.